Okay, here we have the function f of x equals x times the square root of 2 minus x squared. We want to find the open intervals on which this function is increasing and the open intervals on which it's decreasing. So basically what we have to do is make a sign chart for f prime of x. So let's start by finding f prime of x. So f of x is going to be rewriting this as a power. We have x times 2 minus x squared to the power of 1/2. So to find the derivative, we have to use the product rule. So it's the derivative of the first, which is just 1, times the second, plus the first times the derivative of the second. So it's 1/2 times 2 minus x squared raised to the 1/2 minus 1, which is negative 1/2, times the derivative of 2x squared, times the derivative of 2 minus x squared, which is minus 2x. So this is equal to 2 minus x squared to the 1/2. Here these 2's cancel. We have minus x times x, so minus x squared. And we pop this down into the denominator, so 2 minus x squared to the positive 1/2. Now let's get a common denominator here. It's going to be, so we can view this as being over 1. So here we take the top and the bottom and multiply by this denominator. So we have times 2 minus x squared to the 1/2, 2 minus x squared to the 1/2 times 1. So in the top we end up with 2 minus x squared to the 1/2 times 2 minus x squared to the 1/2. That's just 2 minus x squared. Then minus this x squared divided by this denominator, 2 minus x squared to the 1/2. So 2 minus x squared, that's 2 minus 2x squared, divided by 2 minus x squared to the 1/2. On this numerator we can take out a 2, so that's going to be 2 times 1 minus x squared, divided by 2 minus x squared to the 1/2. So that's 2 times 1 plus x times 1 minus x, all divided by 2 minus x squared to the 1/2. Okay, so now we're ready to make a sign chart for f prime of x. So f prime of x is equal to 0 if x is negative 1, or if x is 1. If x is equal to the square root of 2, the derivative is undefined. So square root of 2, that's a little bit bigger than 1. And also if x is negative root 2, which it's like about 1.41 root 2 is. So the derivative is undefined. And we also know that we cannot take the square root, this power 1/2, that means take the square root. We also know we can't take the square root of a negative number. So here, if we go back to the original function and check out the domain, we see that if x squared is bigger than 2, then this is going to be negative. So in fact, our domain for f ends at root 2 here and negative root 2 in this direction. Okay, so here we have all the pieces of information for the sign chart for f prime. So now we pick a value of x between negative root 2 and negative 1. I'll choose maybe negative 1.1. Then I'll choose 0. Then I'll choose 1.1. So if x is equal to negative 1.1, I have 1 plus negative 1.1, that's negative. 1 minus a negative 1.1, positive. 2 minus 1.1 squared, that's going to be positive. So negative, positive, positive, we have negative. When x is 0, I have 1 plus 0, so that's positive. 1 minus 0, positive. 2 minus 0, positive. Finally, when x is 1.1, we have positive. 1 minus 1.1 is negative. 2 minus 1.1 squared is positive. So we see that f, since f prime is negative here and here, f is going to be increasing. So from negative, it's going to be increasing here from negative 1 to 1 because f prime is positive. So negative 1 comma 1. And it is decreasing from negative root 2 to negative 1, union 1 to root 2. Okay, now let's classify the relative extrema of f of x. So to do that, we need to look at the sign chart for f prime. Okay, so on the sign chart here, I'm going to denote which ones are critical numbers. Okay, so here, f prime of x is undefined, but negative root 2 is an endpoint of this domain, because the domain of f is negative root 2 comma root 2. So I'm going to test it for an extremum, but I'm not going to call it a critical number. This point here, x equals negative 1, where the derivative is undefined, that's a critical number. I'm sorry, where the derivative is 0, that's a critical number. This x value at 1, where the derivative is 0, that's also a critical number, because 0 is inside the domain, it's not an endpoint. And this value, x equals root 2, where the derivative is undefined, that's an endpoint. So I'll call those E for endpoints because I examine them separately or in a different way. So for the critical numbers, I'm going to use the first derivative test for relative extrema. So since at this critical number, the function is going, the derivative goes from negative, so decreasing, to positive, we have a relative minimum there. At this critical number, the function is going from positive to negative. Sorry, the derivative is going from positive to negative, so the function has a relative max. So we have a relative min at the point negative 1, and then to get the y-coordinate, we have to plug negative 1 into the function. So it's negative 1 times the square root of 2 minus negative 1 squared. So that's negative 1 comma negative square root of 2 minus negative 1 squared is 1. So that's negative 1 comma negative 1. So we have a relative minimum there. We have a relative maximum where x equals 1. So 1, and then if we plug 1 into the function, we get 1 again. So relative minimum so these critical numbers, we have a relative minimum at that one, a relative maximum at that one. Now we check the endpoints separately. So this left endpoint of x equals negative root 2. So we have some y value where x equals negative root 2, and the function is decreasing after that. So we have a relative maximum there. So we have negative root 2. And if we plug negative root 2 into x in the function, we get 2 minus negative root 2 squared. That's going to be 2. So 2 minus 2 is 0, so negative root 2 comma 0. And then finally, at this endpoint here of root 2, the function falls till it hits x equals root 2. So that's going to be the lowest of all the values nearby. So we have a relative minimum there. So root 2, and again, if we plug root 2 into this function, we get 0 as well. Okay, so that's the those are the relative extreme of f of x.